Good morning, good evening, or good night. I don't know when you're watching, but if you're watching, thank you at least for watching. Today's lecture is going to be on section 2.18. We're going to be recognizing chemical reactions. So let's get started. Alrighty, so who's going to help me read this introduction about cooking pizza?
Making a pizza can be as easy as buying a take and bake from a store and putting it in the oven to mixing up the dough and loading it up with your favorite toppings before baking it. How do you know when it is done? The most obvious sign is that the crust turns light brown. The dough is no longer flexible but much more solid. Maybe the cheese has melted. You want the pizza to be cooked, not half raw.
Have you ever done this, guys? Maybe not for pizza, but have you ever been cooking and you take it out too early and it's not fully cooked? You know, like chicken or maybe even anything like, sopa, uh, arroz, rice, fideo. Has anybody ever started cooking and then you took it out too early and it wasn't done cooking? I know I did that. When I was starting to learn how to cook, I would take it out too early or I would leave it too long, right? Especially when I was doing fideo. I always ended up burning the fideo instead of, just I would always have it too hot. But that was just me. Now, anytime we cook, there is a time where you realize, hey, I'm done. It's done. If I cook it any longer, it's gonna burn and it's gonna ruin, right? When we're especially like scrambled eggs, when that scrambled egg is ready to go because it's no longer like gooey or liquidy. You see it nice and solid. It's got that real pretty color. Those are the indicators. That's the indicator. That's the evidence. That's the sign that says, hey, stop. Turn off the heat. Stop cooking. Because if you cook it anymore, it's gonna get overdone. Right? And overdone food is not really tasty. So the same thing happens. There are signs, there's evidence, right? Anytime you have a crime, there's gonna be evidence left behind. Well, anytime you have a chemical reaction, there's gonna be evidence that it's done, that a chemical change has occurred, and your substance has completely changed composition. Okay, so let's check it out. Let's get done. Recognizing chemical reactions. How can you tell if a chemical reaction is taking place? There are four visual clues that indicate that a chemical reaction has likely occurred. Okay, clues. I like to call them evidence or signs, right? Like a stop sign. That's the same thing here, okay? There's going to be four signs, four evidences to show that a chemical reaction has occurred. The first sign is a change of color. If you have two clear solutions and you combine them and they make a different color, more than likely a chemical reaction has taken place. Okay? For a color change, it's usually you'll have color change and then something else to prove that a chemical change has occurred. The second one, the second sign or the second piece of evidence is a gas is produced. Okay, and when I say a gas is produced, just like when water starts to boil, you'll see bubbles. If you mix a solution with a powder and it starts to bubble up like vinegar and baking soda, you're gonna see bubbles. That just means the gas is being released. Okay, if you have something that's covered and all of a sudden you uncover it and you smell something, you smell an ugly odor, that is the same thing as producing a gas. Okay. The third piece of evidence or sign is a solid forms. Okay, a solid, right? You got two liquids, and all of a sudden there's all these solid flakes floating around. That means that a reaction has occurred, and we have a special name for that solid. We call it a precipitate. Okay, a precipitate means that all of a sudden there's a solid floating around in there. Okay, and it can look white, it could look yellow, it can look black, it can look all sorts of colors. Okay, it just depends on the compounds that are combining. Number 4 is a transfer of energy. Okay, a transfer of energy can usually be seen, right? If you see light, that is evidence that there's a transfer of energy. Energy is being released in the form of light. Um, a transfer of energy can also be indicated with a temperature change. If you see that your thermometer is going higher or lower after the reaction has started, then there is energy being exchanged. So, more than likely, a chemical reaction has occurred. Okay. Now we're going to talk about examples of each of these indicators, okay, or clues as they call them, visual clues. All right. So remember, if it's a color, it's 1. If it's a gas, it's 2. If a solid forms, it's 3. And if you see energy, it's 4. So let's read and see what type of evidence of a reaction do we have. So number 1, mercury 2 oxide is a red solid. A red solid. And here you have an example in a picture. To me, it don't look red. To me, it looks orange, red-orange color. All right, so let's say you heat up this mercury oxide to above 500 degrees Celsius. Okay, you get that substance so hot that it goes over 500 degrees Celsius. It will decompose. It's going to break apart. It's going to do a decomposition reaction. You have a solid compound breaking up into elements, okay? And in this case, it's going to break up into mercury and oxygen gas. The red color of mercury oxide reactants becomes silver in color of mercury. The color change is a sign that a reaction has occurred. All right. So, is there any other evidence that you can probably measure as far as a change other than the change in color? Did you would you see a gas? Would you see a solid? Or would you might get a change in energy if you are heating something up? What other indicator was probably in there? We had to get it to 500 degrees. Are we transferring energy anytime we get our mixtures to 500 degrees? Yes, guys. So not only was there a change in color, but there's definitely a transfer of energy, number 4. Okay? And here you have an example of what it's going to look like. This picture on top, that was the before. This picture on bottom, that is the after, okay? This is before being heated. This is after being heated. It goes from being this red-orange color to silver, okay? Right? Mercury, regular mercury, looks silver in color. That's what we have here. All right? Questions, guys. Questions. That's the first example. Example number 2. When zinc reacts with hydrochloric acid is a very strong acid. If you have pure hydrochloric acid, it can dissolve just about anything. The reaction bubbles vigorously as hydrogen gas is produced. The production of a gas is an indicator that a chemical change has occurred. And you can see that, well, you can barely see, but this solution is bubbling, okay? And they're telling you zinc is reacting with hydrochloric acid and produces bubbles of hydrogen gas. So here you can see bubbling. It's not a great picture. It's not a big picture, but just know that it's bubbling, okay? So a gas is forming, okay? That is the second example. What about when a clear solution of lead 2 nitrate is added to a clear solution of potassium iodide? Okay? What indicators do you see here? They're talking about a yellow solid, but is there another indicator here when you have a clear and a clear solution all of a sudden become yellow? Which indicator would it be? Number 1, 2, or 4? Can we also put in here? What do you think, guys? 2 clear liquids all of a sudden you see this. So yes, I know that number 3 is happening. There's a solid forming. But what else is happening, guys? What other evidence are they providing? Hello?
Color change.
A color change. Thank you, Oscar. Not only is a solid forming, number 3, but there is a change in color, right? They were both clear, and look at that. We got all this yellow all of a sudden. Evidence of a chemical change. Thank you, Oscar. All chemical changes involve transferring energy. When zinc reacts with hydrochloric acid, the test tube becomes warm. Energy is released during the reaction. Some other reactions will absorb energy. Some of them will take energy from wherever they can find it. In this reaction, energy is going out instead of coming in. While energy changes are a potential sign of a chemical reaction, care must be taken to ensure that a chemical reaction is taking place. So just because change in temperature or energy is happening does not mean that it's a chemical. It can also be physical. And they're going to talk to you about some examples. Physical changes also involve transferring energy. If you have a solid and it melts, that means it's absorbing energy. Okay? That's going from a solid to a liquid. While the condensation of a gas releases energy. Condensation. That's when you have a gas turning into a liquid. All right. So basically those gas molecules lose energy enough so that it can go back into a liquid form. But the only way to be certain that a chemical reaction has taken place, excuse me, is to test the composition of the substance. If you test it and it has different properties, it's a different substance, okay? Watch this video, guys, of evidence of a chemical change. This first example is going to change color and it's going to form a solid. And this is that first example that we talked about. So this is potassium iodide. This is lead 2 nitrate. This was that bottle that turned yellow. It's the same reaction, and watch what happens. They're both clear. Look at that. A solid is forming. Look at that, guys. So it went from being clear to yellow and a solid formed. Here we're going to have a change in temperature and gas being released. It's at 20 degrees Celsius. That means room temperature. Just as cold as it is right now in your room. All right, everybody see those bubbles? Gas is being released. All right, so we're going to check that temperature, see if it changed. So if you check it out here, you notice it was at 20 degrees before the reaction occurred. It dropped 1, 2, 3, 4 degrees. It dropped 4 degrees to 16 degrees Celsius. More than likely, energy is being released into the system. And the system means just the environment, okay? Sorry, I forgot to tell you that. Sorry. In this one, you're going to be seeing oxygen being released. So he's going to be lighting that toothpick on fire and then kind of like letting it go out. He's going to put it in the test tube and see if that little bit of energy is enough or enough oxygen is being released to light up that toothpick back on fire. Here's the toothpick. Okay, he's lighting it up. He's going to turn it off. Not enough gas yet. He's going to wait a little bit longer. And look at that. Oh, nothing yet. Okay. Let the reaction continue. He's waiting a little longer. Oh, look. There's oxygen. That oxygen that's in there, remember, oxygen gas is flammable. So with enough energy, it will light up that toothpick. This one says it's explosions, but what they mean here is heat and energy transfer. Energy is forming in the form of light. So this is a group 1 metal. This is one of those metals that we were watching last week. Watch what happens. So this is a small piece. You can see heat and light. Energy is being transferred. In this case, energy is going into the environment. All right, now they're getting a bigger piece. Let's see what happens. A lot of action, as you can tell. Alrighty. One more. It's short.
We now know how to recognize when a physical reaction has taken place. But how can we know a chemical reaction has taken place? You can tell by the evidence. When a chemical reaction has taken place, one or more of the following events will occur. Bubbles of gas are released. Heat is released or absorbed. Light is given off. Precipitate is formed from the solutions. A smell is produced, or there is a change in color. And remember, the product of the reaction is always different than the original reactants. Bubbles of gas are formed when gas is released and rises to the top of the solution. For example, carbon dioxide gas is released when sodium bicarbonate is mixed with acetic acid, more commonly known as vinegar. Heat is released and light is given off when a reactant burns. As a result, chemical bonds are broken quickly and in large quantities. For example, paper being burned in the presence of oxygen produces heat and releases light. Heat can also be absorbed when chemical bonds are formed quickly and in large quantities. A precipitate is formed when two liquids are mixed together and a solid compound comes out of the solution. For example, when silver nitrate is mixed with sodium chloride, black specks of silver chloride fall to the bottom of the container. A change in color occurs when two compounds react, and the resulting compound is different in color than the original compounds. Color change indicators are used in many chemical reactions to indicate reaction completion. For example, when sulfuric acid is added to water and a phenolphthalein indicator, the solution turns from clear to pink. Smells can be given off when vapors are formed in a chemical reaction. One example of this occurs when iron filings are mixed with sulfur and then heated in the presence of oxygen. The product, sulfur dioxide, smells like rotten eggs. Another example is sour milk. The smell is produced because bacteria react with the milk to produce a vapor, which you can detect with your nose. The identity of the original substance changes due to a chemical reaction. For example, iron and oxygen combine to form rust, which is very different from either of the reactants.
Any questions, guys? Any questions on any of the videos? Any of the examples that they provided for us? Okay. All right, so let's summarize. Let's figure out. There are 4 visual clues that indicate a chemical reaction is likely to occur. The first one is a change in color. The second one is gases produced. The third is a solid will form, also known as a precipitate. And evidence number 4 is a change in energy, okay? And that could be in the form of heat or light, or it can be in a change in temperature. Temperature will go up or temperature go down. You got 3 questions that you're going to be doing for your review. What was the color change when mercury 2 oxide was heated? What happened when zinc metal was mixed with hydrochloric acid? And what happens when lead nitrate and potassium iodide are mixed? Okay.